The start of this is the Light and Matter section of 2009. There's two questions which are kind of the opposite way around of each other. So they're talking about the two different experiments that show that light's either a wave or a particle. So at the time of Young's double slit, there were two competing models for the nature of light, and that is wave or particle. Explain how Young's experiment supported one of these models compared with the other. So the Young's double slit showed that light was a wave, but I'm going to explain Young's double slit and then hopefully my answer will be wave. For 3 marks, I'm going to go for 3 dot points. So in his experiment, Young observed alternating patches of bright and dark bands. This is on a screen. So you'll have in your notes somewhere that he has his double slits, and then on a screen he's got bright and dark bands. Right, so I've said what he observes, and now I'm going to say why that's the case. These are cores. These can only be explained. These bright and dark bands can only be explained as constructive or destructive interference of waves. Generally, particles don't interfere. With each other. And there's my answer, so it's a wave model of light. Alright, the next one's about the photoelectric effect and Einstein's explanation of it. So explain briefly how the results of the photoelectric effect supported the competing model, so the particle model of light, to the one supported by Young's experiment. Alright, so in photoelectric effect, the maximum kinetic energy of the ejected electrons it depends not on intensity but on frequency. Right, so this is the main effect that I like to talk about. You have to go through your notes and have another look at what the photoelectric effect is and the light hitting the metal and the metal emitting electrons. But the main thing is those electrons that are emitted, the kinetic energy of them, it depends not on the intensity of that light, not how bright it is, but on the frequency of that light. So why was this an issue and how was it explained with the particle model and not the wave model? So a wave model predicted the intensity would affect kinetic energy of the electrons. Now we have a particle model explains this as each electron absorbs one photon. It's a particle of light, and each photon has energy equal to hf. So it depends on its frequency.